now we're in 6.8b. Let's just go over the vocabulary. So this is an inequality, and the solution set of an inequality is the colored area. Sometimes it includes the boundary and sometimes it excludes the boundary. When it's dashed, it's excluding the boundary. So we did that in the last section. So now we're doing a system of inequalities, and a system just means more than one inequality together. So here's a system of inequalities, here's a system, and here's a system. It just means more than one, a group of them. So how do we find the solution set of a system of inequalities? All we do is we take the first one, we graph it, we shade it. We do the second one, we graph it, we shade it, and we put it on the same graph. And then we look for the area that's been shaded twice. And you can see this blue area has been shaded. This is the red area. Red plus blue is purple. So this has been colored twice, shaded twice. So this is the solution set, this purple area right here. That's all we're doing. So let's do some examples. Let's go to page 4. So it says determine the solution set for the system of inequalities. So let's look at number 1. And if we look at the equation number 1, we can see that y is by itself. So I can use the slope-intercept form for graphing this inequality. So let's do the first one. So y is less than, okay, I'm going to graph this. So step 1, we graph the boundary line. The line. Okay, so we change this to an equal sign so we can graph the boundary line. So this is my y-intercept, step 1, and this is my slope. Because there's no number there, there's really a 1 that's hiding. So my slope is -1, but we need it as a fraction, so we always just, any number that we have by itself, if we want to make it a slope as a fraction, we just put it over 1. So for example, if my slope is 10, just put it over 1. If my slope is 5, just put it over 1. If my slope is 2, just put it over 1, and that makes it a fraction. Always 1. So I'm going to put a point at 1 on the y-axis, +1, that's where we start. Let's do it in pink. Okay, now the slope says go down 1, right 1. So down 1, right 1, down 1, right 1, down 1, right 1. So there's some points so I can make my line. Oh, wait a minute, is it dashed or is it solid? So you can see that it doesn't have an equal sign, so it's got to be dashed. Okay, so let's make a dashed line. There, so that's line 1. So now we have to decide, step 2, color one side. Okay, so what I'm going to do is I'm going to take any point from the graph that's not on the boundary line and substitute it into the inequality to see if it's true or false. I like to take the easiest point, which is 0, 0. So I'm going to take 0, 0 and substitute it into our inequality. So x is 0, y is 0. I have 1, but I lose nothing. I still have 1. So now I'm going to read it. It doesn't matter which way you read it. This says 1. I touch the big side. So 1 is bigger than 0. 1 is bigger than 0. 1 is bigger than 0. Yeah, that's true. Okay. So that means when I substitute this point into our inequality, it's true. That means all the points on this side, when I substitute them into the inequality, are true, and all the points on this side are false. And we always shade or color the true side. Now we're going to do this again. but we're going to do it for the second equation, or inequality. Okay, so step 1, graph the line. Okay, so if I look at this, y is not by itself, so I'm going to use the xy intercept method to graph this line. So let's write it out with an equal sign. And I'm going to make a little table of values. Oops, not 0, y. 0, 0. So we're saying if x equals 0, let's put this equation here. X minus y equals 5. We're going to substitute the 0 in for x. So this says minus y is 5. So there's really a 1 here. So to get rid of that minus 1, I'm going to divide by minus 1, divide by minus 1. That's 1. Same over same as 1. So y equals minus 5. So if x is 0, y is minus 5. Okay, so now we're going to do if y is 0. Let's write out the equation. So instead of y, we're going to put a 0 here. Well, that was faster. So if y is 0, x is 5. So there's our 2 points. I'll write them down here. So that's 0, negative 5, and that's 5, 0. So these are our 2 x and y intercepts. And now we can graph this line. So this is x, this is y. X goes this way, y goes up and down. So it says don't go left and right, just go down 5. There. This says go 5 right, but don't go up and down. Okay, so there's our 2 points. So now I have to, but is it dashed or solid? If I look at this, there's no equal sign here, so it's going to be another dashed line. So I'm going to draw the line, but make sure it's dashed. And that's my line number 2. Now I have to decide, what color, what side to shade. Okay, so I'm going to pick the easiest point again, 0, 0, and substitute it into this and see, let's say, what side to color. Okay, I'm going to take the easiest point and substitute it into our inequality. Okay. Now I read that. It doesn't matter which way you read it. This says 5 touches the big side. 5 is bigger than 0. 5 is bigger than 0. Is 5 bigger than 0? Yep, that's true. That means if I take this line, that this point is true. So that means everything on this side of the line is true, and everything on this side is false. So this side is true. So I'm going to color this side. Now, the last step is we have to go, what area has been shaded or colored twice? We can see this area here has been shaded or colored twice. So this is my solution set right here. And you can see this is dashed and this is dashed. So the solution set does not include those boundary lines. So any points from this area, if I substitute them into this system of inequalities, these 2 inequalities, both statements will be true. If I choose any point from outside of the solution set, one of those is going to be false, or both of them is going to be false. We'll have some false statements. But any point from this solution set will make both of these true when we substitute them in. Let's do the next question. Okay. So let's look at inequality number 1. Y is by itself, so I'm going to use the slope-intercept form to graph it. So let's look at the first inequality. So first step is I need to graph the line. So let's put it as an equal sign, because we're just going to look at it as a boundary line. We're going to graph the boundary line. Okay, so this is my y-intercept, and this is my slope. The slope always touches the x. But slope is 2, so we put it over 1 to make it a fraction. The 2 is positive, so it means go up. The 1 is positive, so it goes right. Okay, so you put a point at -1 on the y-axis, because it's the y-intercept. Here's the y-axis. And it says go up to right 1, up to right 1, up to right 1, up to right 1. And I can do some more here, the same shape. Now let's graph the line. Oh, wait a minute. Dashed or solid? See here, there's an equal sign, greater than or equal to. Because there's an equal sign, it has to be solid. So let's make a solid line. So that's equation 1. So now step 2, color, oops, that's not how you spell color, color one side. So I can pick 0, 0. You can pick any point you want and substitute it into the inequality, but I choose the easiest point. So I'm going to choose 0, 0. And put it into this statement, or put it into this inequality, and if it makes a true statement, then we know this side needs to be colored. So we're going to put 0, 0 into this inequality and see if it makes a true statement. Two times 0 is 0, so that's really just -4. Okay, let's read it this way. 0 is greater than or equal to -4. Let's just make a little number line. So there's 0, there's -4. 0 is bigger. 0 is bigger than -4. 0 is bigger than -4. Yeah, 0 is bigger than -4. That's true. So this side here with the 0, 0 is true. So any point from this side, if I take any point from this side and substitute it into this inequality, will be true, and any point from this side will be false. So I'm going to shade this side of the boundary line. Now let's do inequality number 2. So first we're going to graph the line. Okay, so let's make it a line and change it to an equal sign. So the 2 is our y-intercept, the 3 is our slope. So slope equals -3. Put it over 1 to make it a fraction. Because this is a negative, it makes this go down, and this is a positive, it goes right. Remember your slope, the number on the top is always up and down. Positive, if it's a positive number, go up, negative number, go down. The bottom number is left and right. If it's right, it's positive. If it's left, it's negative. Okay, so we put a point at 2 on the y-axis. So here's 2, and it says go down 3, right 1. 1, 2, 3, 1. 1, 2, 3, 1. 1, 2, 3, 1. Just pretending. And let's see, I can do 1, 1, 2, 3. Let's do 1 there. Okay, so join the dots. Wait. Is it dashed or solid? So here, there's no equal sign, so it's going to be a dashed line. Okay, so this is dashed. That's a dashed line, so that's my line number 2. Now I have to decide what side to color. So step 2, color one side. So what point can I choose? any point I want, I pick an easy one. So I pick 0, 0 because it's the easiest one. So I'm going to take 0, 0 and substitute it into the second inequality and see what kind of statement we get. Three times 0, 0, so I just have 2. Let's read it. It says 2 is bigger than 0. 2 is bigger than 0. 2 is bigger than 0. Yeah, that's true. I always have to say it a few times to make sure I'm correct. So when I take, if I look at this boundary line, this point, when I substitute it in, makes it true. So everything on this side of this line is going to make this inequality true. Any point here I take, and I substitute it into this inequality, will make it true. So that means I have to shade this side. Okay. So now the next step is to go, okay, what area have they both been shaded? Has it been shaded twice? So I'm going, okay, that's been shaded twice. That's twice. So here. So this is my solution set. And you can see here, the boundary line here is included because it's solid. And the boundary line here is dashed. So it's excluded. So we have to be careful to make sure sometimes this side will be dashed or solid. Okay, so this is my solution set. So any point that I take from here and substitute it into both of these, both statements will be true.